So let's just talk about the another important concept in the chapter real numbers, and that is nothing but Euclid's division lemma. What is the meaning of a lemma first? So let us suppose we are talking about what is the meaning of this lemma over here. What is the meaning of lemma? So actually, the meaning of lemma is a proven statement which helps to prove another statement is called as a lemma. So the meaning of lemma is we have a proven statement which is helping us to prove another statement. So here Euclid division lemma is actually a statement which help us to prove another statements. So let's just start with Euclid's division lemma. What is an Euclid division lemma? So Euclid division lemma says that for given positive integer a and b, so let us suppose we are talking about the positive integers a and b, then there exist unique integers q and r. Then for a and b there exist unique integers q and r that are satisfying a particular relationship which says a is equal to bq plus of r, with a condition that the value of r is actually lying in between 0 and b, in which r should be is equal to 0 but it cannot be is equal to b, means r is greater than is equal to 0 but less than b. So what is the meaning of this Euclid division lemma? So let us suppose I am taking any particular two numbers. Let us suppose I am taking 6 and 12. I am taking 6 and 12. So let us suppose I am taking an example over here, and we will discuss about the Euclid division lemma with the help of this particular example. So let us suppose I am taking any particular two numbers, 6 and 12. So obviously 12 is nothing but greater than 6. 12 is nothing but greater than 6. So we will divide 6 and 12. Let us suppose we are taking 12 as a dividend. Always remember you have to take the number as a dividend which is greater among the two. So here 12 is greater among these two numbers, so we are taking 12 as a dividend and 6 as a divisor So let's just divide these two numbers. We know that 6 into 12 is nothing but 6 into 2 is nothing but 12. 6 into 2 is nothing but 12. So the remainder over here is nothing but 0. So we can write this particular formation into a kind of a relationship which says that dividend is equal to divisor. Let us suppose I am writing diy as a divisor into quotient plus of remainder. We can write this particular formation in this relationship which says 12 is equal to divisor is 6 into 2 plus of 0. So this is the relationship. This is the particular kind of a relationship which we already know about, that dividend is nothing but is equal to divisor into quotient plus of remainder. Now let's just convert this 6, 12 to 0 in the formation of a, b, q and r. So let us suppose we are talking about these representations as we are taking 12 as a, we are taking this number as b, this is nothing but the number is as q, so this is nothing but q and this is nothing but our r, which is the remainder. So let us suppose I am converting 12, 6 to 0 in the formation of a, b, q and r. So this representation can be written as a is equal to 6. In place of 6 we can write b into 2. In place of 2 we can write it as q, plus in place of 0 we can write as r. So the representation is nothing but a is equal to bq plus of r. So actually this is nothing but a relationship which is same as that of the relationship which is in the definition of the Euclid division lemma, that a is equal to bq plus of r, where the value of r means that the remainder r should always lies in between 0 and b, means the remainder 0 should always be lesser than this particular number, that is nothing but b. So this is all about the Euclid division lemma. So it is actually as similar as that of this particular relationship which says dividend is equal to divisor into quotient plus of remainder. So always remember this Euclid division lemma, because with the help of this particular lemma we will move on further towards the Euclid division algorithm, and then we will solve some of the important questions of this particular chapter.